Given question, determine the reactions developed for the system as shown in the diagram.
Let us understand given question with the help of diagram. One end of beam AB is fixed at A and other end is free. At free end, load of 14.9 Newton is applied in the downward direction. And due to this load, this end B will try to move in the downward direction. So I will show the final position of the end B. So I will show with the help of dotted lines. So this is the final position of end B. But this beam is fixed at point A. So it will try to rotate about this point A in clockwise direction. So I will show here the direction of rotation. When for the beam one end is fixed and other end is free, then this type of beam is known as cantilever beam. Now if we observe the types of load, this 14.9 Newton as well as 20 Newton is known as the point load. And here is uniformly distributed load 10 Newton per meter. So what is the total load? If we observe the length for which this load is distributed is 2 meter. So total load is 10 multiplied by 2, that is 20 Newton. So I will write here total load for uniformly distributed load, that is equal to 10 multiplied by 2, 20 Newton. Now what is the exact location of this load? So if we observe here, this total length is 2 meters, so exact location, and that is known as centroid. Centroid is always the middle point. So for 2 meter we can say that middle point is 1 meter from end A. So here is end A. So 1 meter from A. So this information is important for the uniformly distributed load. Now we will show the different forces that are applicable for this diagram. So at end A, this end is fixed and we know that this beam AB will try to rotate in clockwise direction. But at end A, because it is fixed, it will apply the moment of force in the opposite direction about the point A. And so we will show here the moment about A in the opposite direction, that is in the anti-clockwise direction, and this is known as MA. And this end is fixed end and it will try to rotate about this point A. So we can show here the reaction in any direction. So we will show the component of the reaction, that is the horizontal component as well as vertical component. So at end A, I will show horizontal component as a HA and vertical component VA. So this is about the fixed end A. Now we will move to the uniformly distributed load. So total load is 20 Newton and centroid 1 meter from A. So if we take here 1 meter from A, that is the middle point. So I will show here 1 meter. Then I can show here the total load that will apply in the downward direction, that is 20 Newton. And here the location, that is centroid, is 1 meter from A. Now we will move to the next, that is 20 Newton. Now it is inclined at 60 degree and it is located at 2 meter from A. So we will resolve this force into two components, vertical component as well as horizontal component. So we will show here. Now angle is given 60 degree with horizontal component. So how we can define this? So horizontal component 20 cos of 60 and vertical component 20 sin of 60. And this point load at end B 14.9 Newton as it is. Now we have to find out reactions developed, that is HA, VA as well as MA. So how to find out? Now suppose we will consider the equilibrium of this system, then we have to show summation of all vertical forces is equal to 0, summation of all horizontal forces is equal to 0, and the moment of all these forces about this point A is equal to 0. So first we will take summation of all vertical forces is equal to 0. So which are the vertical forces? So first one, in upward direction VA, then in downward direction 20, so we will take minus sign, so minus 20, then minus 20 sin 60, then minus 14.9 is equal to 0. So VA is equal to 52 Newton. Then summation of all horizontal forces is equal to 0. So HA direction is towards right hand side, so we will take plus HA, and here this 20 cos 60, so it is in the opposite direction, so we will take minus 20 cos 60 is equal to 0. So HA is equal to 10 Newton. So we will get these two components, that is vertical and horizontal components. So we can, from these two components we can say that here is the reaction at point A. Now we have to find out moment about this A. So how to find out? So we can say that summation of moment of all these forces about this point A is equal to 0. So moment at A is given MA and it is in anti-clockwise direction. So for anti-clockwise direction we will use negative sign. Now we will move for the next, that is for 20 Newton, that is for uniformly distributed load. Now if I move the compass about point A in the direction of 20 Newton, then here is the direction which is in clockwise direction. So we have to use the positive sign. So 20 multiplied by perpendicular distance. So here is the perpendicular distance 1 meter. So plus 20 multiplied by 1. So I have written here 10 into 2. 10 into 2, that is 20 multiplied by 1. Now next, here is 20 sin 60. So again it is in the clockwise direction, so we have to use positive sign. So 20 sin 60 multiplied by perpendicular distance, so it is equal to 2 meter. Now if we move to the horizontal component, then if we extend this line of action of force, then it is passing through the point A. So perpendicular distance is 0, so we are not going to consider this component. Now next is 14.9. So it is also in clockwise direction, so we will take positive sign. 14.9 into perpendicular distance 2 plus 1, 3. So here we have to use 14.9. Now when we solve this, then we will get the answer MA is equal to 99 Newton meter.